Welcome to solverfy.
We are asked to use generating functions to find the number of ways to make change for $100. In part A, we're told we can use $10, $20, and $50 bills. The generating function for the $10 bills, we can make any multiple of $10 with $10 bills. And so the generating function is going to be including all powers of x, which are multiples of 10. So this is 1 plus x to the 10th, plus x to the 20th, plus x to the 30th, and so on. For the $20 bill, we can make any multiple of $20, so the generating function is going to include all powers of x, which are divisible by 20. So this is 1 plus x to the 20th, plus x to the 40th, and so on. And for the $50 bill, we can make any dollar amount which is divisible by 50, and so it follows that the generating function will contain any power of x which is divisible by 50. So this is 1 plus x to the 50th plus x to the 100th plus x to the 150th, and so on. And the total generating function is the product of these three generating functions, which is 1 plus x to the 10th plus x to the 20th, and so on, times 1 plus x to the 20th plus x to the 40th, and so on, times 1 plus x to the 50th plus x to the 100th, and so on. And since we're trying to make change for $100, we want to find the coefficient in the expansion of this generating function of x to the 100. And so, first of all, we have that we can abbreviate this as 1 plus x to the 10th plus x to the 20th up to, and then x to the 100th times 1 plus x to the 20th plus x to the 40th up to x to the 100th times 1 plus x to the 50th plus x to the 100th. And then using a computer algebra system, we can expand this sum, and we find that the coefficient of x to the 100 is going to be 10. So there are 10 ways to make change. In part B, we're asked to make change using $5, $10, $20, and $50 bills. We already have the generating functions for $10, $20, and $50 bills. But for $5 bills, we can make any dollar amount which is a multiple of 5. So the generating function will contain any multiple, any power of x which is divisible by 5. So this is 1 plus x to the 5th plus x to the 10th, and so on. And we have the generating function in total is going to be the product of all four generating functions. So this is going to be 1 plus x to the 5th plus x to the 10th, and so on, times 1 plus x to the 10th plus x to the 20th, and so on, times 1 plus x to the 20th plus x to the 40th, and so on. And finally, times 1 plus x to the 50th plus x to the 100th, and so on. Because we're looking to make change for $100, we want to find the coefficient of x to the 100. To do this, first notice that the sum can be abbreviated if we're only looking for the coefficient of x to the 100 as 1 plus x to the 5th plus x to the 10th up to x to the 100th times 1 plus x to the 10th plus x to the 20th up to x to the 100th times 1 plus x to the 20th plus x to the 40th up to x to the 100th, and finally times 1 plus x to the 50th plus x to the 100th. And using a computer algebra system, we expand this generating function and find the coefficient of x to the 100, a100, is equal to 49 in this case. So there's 49 ways to make change. In part C, we're asked to make change for $100 using $5 bills, $10 bills, $20 bills, and $50 bills if at least one bill of each denomination is used. So the way this is different is we have to have at least one bill of each denomination. What this means is we can only have powers of x that are going to be greater than or equal to the bill amount times 1. And so we have the new generating function for $5 bills is now going to be x to the 5th plus x to the 10th, and so on. The new generating function for $10 bills is going to be x to the 10th plus x to the 20th, and so on. The new generating function for $20 bills is x to the 20th plus x to the 40th, and so on. And the new generating function for $50 bills is going to be x to the 50th plus x to the 100th, and so on. And we have that the total generating function is the product of all 5 of these, or all 4 of these generating functions. So this is the function x to the 5th plus x to the 10th plus, and so on, times x to the 10th plus x to the 20th, and so on, times x to the 20th plus x to the 40th, and so on, times x to the 50th plus x to the 100th, and so on. And since we're trying to make change for a $100 bill, we want to find the coefficient of x to the 100. And before we do this, one way to simplify this expression is to first factoring out x to the 5th and x to the 10th, x to the 20th and x to the 50th. This gives us x to the 50 plus 20 plus 10 plus 5, which is x to the 85. And then, after we've done that, we can rewrite this as 1 plus x to the 5th and so on, times 1 plus x to the 10th and so on, times 1 plus x to the 20th and so on, times 1 plus x to the 50th and so on. And so we can now abbreviate this as x to the 85th times, well, we have that this needs to sum to 100, so we have that 100 minus 85 is 15, divided by 5 is 3, so we can go up from 1 plus x to the 5th plus x to the 10th up to x to the 15th. That's our maximum. And in the case of this next sum, we have 1 plus x to the 10th, but if we go to x to the 20th, then there's no way that could work. And for this next sum, we have 1, and for the last sum, we have 1. And so we reduce this sum considerably. We have this is equal to x to the 85th times, and multiplying these out, we have 1 plus, we have x to the 10th there, we have an x to the 5th, and then we have 2x to the 10ths, and we have next to the 15th, and next to the 15th, so plus 2x to the 15ths, and then we also have plus an x to the 20th, and finally plus an x to the 25th. We have that this is going to be equal to x to the 85th plus x to the 90th plus 2x to the 95th plus 2x to the 100th plus x to the 105th plus x to the 110th. And so we have that the coefficient of x to the 100 is 2. Finally, in Part D, we're asked to make change for $100 using $5 bills, $10 bills, and $20 bills if at least one and no more than 4 of each denomination is used. So the restriction that at least one and no more than 4 of each denomination is used implies that for the $5 bill, the generating function starts with x to the 5th for the at least one denomination and ends at x to the 20th for at most 4. So x to the 5th plus x to the 10th plus x to the 15th plus x to the 20th. Likewise, for the $10 bill, we have x to the 10th plus x to the 20th plus x to the 30th plus x to the 40th. And to the $20 bill, we have x to the 20th plus x to the 40th plus x to the 60th plus x to the 80th. And we have that the total generating function is the product of these three generating functions. So this is x to the 5th plus x to the 10th plus x to the 15th plus x to the 20th times x to the 10th plus x to the 20th plus x to the 30th plus x to the 40th times, I'll write a separate line, x to the 20th plus x to the 40th plus x to the 60th plus x to the 80th. And I can simplify this by first factoring out an x to the 5th, x to the 10th, and an x to the 20th. So I get x to the 20 plus 10 plus 5, which which is x to the 35th, times 1 plus x to the 5th times 1 plus x to the 10th plus x to the 20th plus x to the 30th times 1 plus x to the 20th plus x to the 40th plus x to the 60th. And while we could use a computer algebra system, another way we can do this is recognize that this is the same as x to the 35th times, and this is 1 minus x to the 20th, excuse me, over 1 minus x to the 5th While we could do this by hand, the easiest way is just going to be to use a computer algebra system. And so, since we're looking for the number of ways to make change for a $100 bill, we want to find the coefficient of x to the 100 in the expansion. And if we use a computer algebra system, we find that the coefficient of x to the 100 is 4.